All right, so good morning, everyone. We'll start off with the squirrel scale. So how are you feeling today? We've got a bunch of images of squirrels, and so we'll ask you to identify and to type into the chat, but don't hit enter yet for which squirrel you're feeling most like on the squirrel scale. All right, so then we'll do a countdown. I'll give you a couple more seconds and then we'll do a countdown. And how are you feeling on the squirrel scale? Ready? 3, 2, 1, hit enter. Oh. All right, we've got some. Kirsty's with Kirsty, you're not an 8 today. You're
I'm not an 8 today. I'm a 5.
Yeah.
It's Saturday. I'm a 5.
All right, Pedro's with you on that.
There's
So
a lot.
Maria.
Yeah.
Everyone's with that.
Except Carmelita. Carmelita.
All right. Thanks for sharing where you're at. As we're going through today, then we want to think about these engaged participant outcomes. We're going to think about how we might co-construct with students, got to have checklists to support students in writing evidence-based explanations. This whole topic, by the way, is pressing students for evidence-based explanations. So how to got to have a checklist play into that. Also then how to support students in using evidence to account for different aspects of their explanatory model. And how might we engage all students in authentic disciplinary discourse around constructing and defending explanations. So thank you for being here. We'll ask you to, just like in person, be with us all in. Please remain muted until we have opportunities to share out. Please keep your camera on if possible and respond when prompted. So this is a train the trainers PD, which means that we're going to operate with 2 different roles. So one role is as a facilitator, as a leader. The other role is as a learner. So when you see a lavender slide like this with a lavender background, then that's an indication that we're in the facilitator/leader role. We'll be reflecting as leaders. And when it's a white background slide, then that's indicating that we're in the learner mode. These are going to be slides that you would present to your staff. So here's our first white background slide. So these are the instructional foci for local district East. Today we're going to continue our focus on deep clarity of learning goals. Specifically, we're going to build precision of pedagogy as we press for evidence-based explanations. And as a part of that, we're going to look for opportunities to amplify student voice. And so always connecting back to standards. So what is standards-based explanation? Well, what is standards-based instruction? It's where students are figuring things out. What are they figuring out? They're figuring out the disciplinary core ideas. If students aren't figuring things out, I mean, this is the first question. Really, this is a key question for you as leaders. What are students figuring out? When you walk into a classroom, when you go to help, when you go and do some peer observations, when you're looking at student work, when you're looking at lesson plans, when you're designing your own lesson and unit plans, the question is, what are students trying to figure out? If that answer is not a DCI and that the students are trying to figure it out, then it's automatically not in GSS. So number 1, what are they figuring out? They're figuring out in DCI. Number 2, how are they figuring it out? They're figuring it out through a science and engineering practice. And along the way, they're going to engage in thinking like a scientist or an engineer through the cross-cutting concepts. So how are they thinking about it? And why are they doing this? They're doing all of this to connect to the real world, to explain an anchoring phenomenon, an anchoring event, to help to construct a storyline about why something happens. So key student moves are the science and engineering practices 2, 6, and 8. They are developing and using models, constructing explanations or designing solutions, and engaging in argumentation from evidence. The commonality between them is claim, evidence, reasoning, or justifying. And we've been going over a 4-part series. This is the 4th in the 4-part series of the teacher moves. The teacher moves are called the ambitious science teaching practices. We've gone through planning for engagement with important science ideas. That was our first PD. We looked at number 2, how do we elicit students' ideas? Number 3, how do we support ongoing changes in thinking? And today, next slide, please, we're on number 4, pressing for evidence-based explanations. Now I will hand it over to Kirsty.
All right, good morning, everyone. So today we're really looking at pressing for evidence-based explanations. And so here's a graphic, and you can see at the center of the graphic, we have both modeling and constructing explanations, because a lot of times we like to think of these two as going hand in hand. You can do one without the other, but for the majority of the time, every time we use a model, we have kids explain it. We have our students explain them. So modeling, it either motivates other practices or they change as a result of engaging in those other practices. So we looked at modeling when we looked at ASTP4, eliciting student ideas. That was kind of our big focus around that. So now we're going to tie into, now we've gone through this whole series of lessons in this unit. So how can we tightly couple that with these evidence-based explanations, these strong evidence explanations that we're really working for students to produce? So for today, we have 3 major parts that we're kind of going to look at. The first is co-constructing a gotta have checklist. And I think the keyword here is co-constructing. This isn't something that we're just giving to students, but rather we're pulling these ideas out of students, seeing what they're identifying as the most important parts. Then pressing for evidence-based explanations and models. So these are the first 2 are really where our big focus is today. And the third is assessing for understanding. So by doing the co-constructing of the gotta have checklist and pressing for those evidence-based explanations, this all leads to that assessing for understanding, where you as the teacher are able to see, oh, my kids are getting this, or oh, they're not, there's still a gap in their knowledge. We need to go back and fill that gap. So we're going to engage in a little activity, and we're going to look at this initial model of the lawn chair flight. So students, this was 9th grade physics, I believe is what we came to, a 9th grade physics class. This was a phenomenon for students, the lawn chair flight. Eric Rohner took it upon himself to bring to life the movie Up and say, hey, it can be done. So he attached all of these helium-filled balloons to his lawn chair and took flight. And then he was able to kind of judge, how many balloons he had to shoot so that he could safely land his lawn chair. So he took flight and landed. And students were asked to observe the phenomenon and then construct a model and explanation. So you can see this was their first model, their initial model. After creating their initial model, students went through a series of lessons and were able to co-create this gotta have checklist. And this is going to be our focus for this activity, is this gotta have checklist. So once students were given the gotta have checklist, they came back and created these final models. And again, you can see the difference in just the length of the explanation or the detail in the modeling. So Craig just put the participant slide deck in the chat. And in that participant slide deck, you have the initial, the gotta have checklist, and the final models. So what we're going to do now is put you guys into breakout rooms. And first question, how does the gotta have checklist help students refine their initial models? So how did that checklist help bring the students to be able to produce something like this final model? And then the second question, how is a gotta have checklist different from a rubric? Okay. So we're going to put you guys into breakout rooms for about 5 minutes to discuss these questions, talk about what you see, and then we'll come back and whole group share. Are there any questions? Everyone, welcome back. So you can go ahead and feel free to unmute or share in the chat, but let's focus on that first question. And how does this gotta have checklist help students refine those initial models?
So we started noticing the difference between the first image and the second image. We noticed that the first image had like very limited number of forces drawn in there. And if we compared it to the second diagram, we noticed that there were a lot of forces, you know, in the balloon, on the person, gravity, upward force, tension between the strings. And we said that the gotta have checklist pretty much provided some sort of guidance for students as far as what they needed to do, right? So it's like going back to the DCIs, right? Or the standards for students to be able to describe what they're trying to show, which is what are the forces happening in this model. And again, this all connects back to the phenomena. What are some of the things that they were observing? This is what my group members mentioned. So I don't know if anybody else wants to mention something else.
Any other thoughts? Thank you for sharing.
In my group, they were talking about this as well, but in addition, they were talking about the difference between a rubric and the gotta have checklist.
Yeah.
And I'm sorry, is it Rhea or Raya? How do you pronounce your first name?
Raya.
So Rhea, can you share what you were saying about the difference?
Yes, so the checklist is easier for students. It's more student friendly. It lets the students know what the teacher is looking for, and it's faster for us to give feedback. The rubric is more for grading purposes, and it's not as easy to use sometimes for students. So the checklist is like faster. Do I have that? Do I have this? And I used it recently, the checklist and then the rubric, and I think it's valuable to include both for students.
Awesome. Thank you. Anyone else? The differences? Any thoughts on that? All right. Well, one thing that kind of want to point out is a huge difference between, again, the gotta have checklist and the rubric is that the gotta have checklist allows for misconceptions to present themselves. Typically a rubric, is kind of a little bit more specific and doesn't give away all of the correct information, but, there are, identifies 3 types of forces, whereas this just shows all the forces acting. So there could be 3, there could be 10. But it also, I identified whether the forces in each panel are balanced and unbalanced. If students have a misconception around that, they don't know if it's going to be balanced or unbalanced and could still misidentify. So it's a little bit more open-ended, and it is that quick, do I have this? Do I have this? Do I have this? Did I do these things? As opposed to that more detailed rubric where they're really looking at, okay, I need to really hone in on my, explanation or model and see what I've included. But the gotta have checklist can also help lead you to that rubric development. So they shouldn't be completely separate entities either, right? if you're giving them this gotta have checklist, your rubric shouldn't ignore all of these things. We want to have congruity with that as well. All right, thank you everyone for sharing. So now we're going to switch our hats. We're going to go into that facilitator mode and reflect kind of on this activity. So what are some key points you want to make sure to highlight with your department or your teachers if you do this activity with them? What are some logistical or planning issues you might consider or alternative ways to do this? Maybe having them bring in their own student work or their own checklist and kind of look at the differences, things like that. Or what are some possible teacher responses or potential challenges to consider when doing this activity with your teachers? So we'll put you guys back into your breakout rooms and give you guys a second again to look through this or to reflect on these questions. And I know Craig did link the deck in the chat, so you have access to this. So just in case you want to open it up and have this slide, you guys have that available as well. Are there any questions before breakout? No? All right. So would anyone like to share anything that they feel that they would do with their department? Maybe give ideas.
I actually had a question.
Yeah.
So the question was like the sequencing. Do we give the normal instructions to the students and then they try it and then refine it with a bullet, like anticipate the shortfalls that the student explanations and diagrams would have, and then make a checklist? Or do we just give the checklist first from the get-go?
So for the initial model, that's just that initial eliciting of ideas based on what they kind of know, what their initial thoughts on it are. And we're going to get into how you co-construct the checklist, but the checklist is developed over the length of the unit. So as you guys are continuously going through the unit and learning, and you're having students identify what's the most important thing we learned and how is it going to help us explain our phenomenon. So then you would co-construct that checklist, and then they would have access to that. That could be posted at the front of the class. That could be given to them. You know, maybe you're just digitally typing it and they have a link to it, but it's something that's developed throughout the unit and then given at the time of either model revision or that final model, final explanation that you're working on.
Thank you. That changes the whole picture I had in my mind of how I would present it to the teachers. Yeah. Thank you so much.
Okay. Yeah, no problem. Anyone else? Any thoughts?
I think for when we're sharing it with our faculty or our teachers, making sure that the teachers see the value in including a checklist, because they might be like, we already have a rubric, why do I need a checklist? So showing them from the student perspective the value of it and how it's different from a rubric. And then when to make it easier on teachers, instead of like recreating something new, just bringing whatever activity or project they were already doing that had a rubric and kind of working backwards to create that checklist. What do I want to see in my students' work?
Yeah, definitely that backwards planning, like type of mentality, especially just when you already have something in place. And that's the hesitation, right? I already have a rubric for this activity. Okay, let's simplify it. So it's just those key points that kids need, and that can turn into the gotta have checklist too. Thank you.
And so this was kind of coming up in our breakout room as well. Really focusing on the why. And I'm just echoing what was just said. But why is this important, right? So as was just said, looking at it through the student lens, why is this important to students? How does this help students refine their thinking? Right, we're shifting, and the big shift here, the big shift is shifting from content to process. So we're not just giving kids questions and answers and asking them to repeat the answers. We're We're helping them to build and construct their own knowledge, which is completely different and requires a different set of tools, than what we've been using. And this is one of those tools that can help with that. So do they understand the why? And why are they doing this?
Yeah. Thank you for sharing. Any final thoughts before we move on to the next section?
I just want to add something.
Yeah.
From what Craig said, there's a chemistry teacher in our school. Of course, you teach chemistry, they know the background, computations, but he said, oh, a student transferred to my class from another class. He knows how to do the process, the steps, but he doesn't know the why of it. Like, how come we're doing these computations for this particular problem? So I'm just echoing it because I heard Craig say why, and then we were talking and he said, oh, he knows everything. He's getting a good grade because it's computation. But when I ask him how come he's doing this, he doesn't get the why of it. So I think this will be a good way to introduce kids on thinking on their own, right, Craig? Like trying to process everything, which is a very slow process for us teachers, because the year that I've noticed, the year that the kids were online, it's so much time, you know, the wait time I give my kids to just answer. I revised the question like 3 or 4 or 5 times. Sometimes I really waited for 5 minutes for just one person. It's like slowly, surely, but I've been using some of what we have here in class. Not everything yet, but slowly. But I get Craig, it's like the why of it. So that's what we need to gear for.
Yeah, the why gives purpose, right? We get that question all the time. Why are we learning this? Why does this matter? So students are uncovering and discovering that why, right? Trying to explain how this man was able to use balloons to float in the air. There's a why. And hopefully they don't go try and do that, but you know, it's piquing that interest and it's making it relevant to them. That's our why.
And
Also, I just want to add in a thought, but I tell my students, you're learning how to learn. You know, the focus should be on learning how to learn so you can adapt to a quickly changing world where we have to learn something basically every month at least. That's new, that's changing. Even driving a battery car was totally different. I don't know how people cope with it if they're not learning on a regular basis, right? Yeah.
I want to add on too, because right now our school is preparing for WASC, actually next school year. So therefore, the administrators started to visit classes. So it feels good when they visited your class and when they will ask a student, what are you doing? What are you doing this? Do you know why you are doing this activity? I mean, if your students will be able to explain right on the spot what they are doing, what is the purpose of what they are doing, I think as a teacher, it feels good because you feel that, oh, at least my student know, at least what they are doing inside the classroom, something like that. So I guess, yes, it's very important. That question, why, once the student will be able to answer that, I think that's really the highlight of the day of your class once they were able to answer that.
Yeah.
the difference, sorry, Kirsty, but the difference between when we go in to observe a fully engaged NGSS class and a traditional class is just what Carmelita was saying. We'll ask students, it doesn't matter which student, we'll ask the A, the B, the C, the D, all the students. It doesn't matter who we ask, but we'll ask the students, why, what are you doing? What are you trying to figure out? They can answer that question. And then why are you trying to figure it out? Like, why are you doing this? They can answer that why question. They know why they're doing this. Which is, and in a traditional classroom, the answers that we get are, I don't know. Teacher told, that's what the teacher, what do you mean? Why are you asking me why I'm doing this? I'm in school. This is what the teacher told me to do. It's a frustrating question for them because there's no answer to them for the why.
Just funny because Craig came into my classroom one time and asked my kids why. And we had gone over why we were doing the lesson and none of them still could answer it. And then they left and I was like, why are we doing this, guys? They're like, well, the glass, right? We're trying to explain the glass. And I'm like, what is this disconnect that I'm seeing? Did you guys get scared? Did you forget? Momentary amnesia? But yeah, it makes a difference when they understand why they're doing something and why we're trying to explain things.
I just want to add in about Carmelita's comment, like admin visiting. So our school admin has been visiting departments. Like every 2 weeks, there's a different admin for each department. So they're rotating. Remember the phenomenon unit chart? So it's on the board, and that was like my lesson for today. I didn't even know she was coming, but the connection, because last time we learned about connecting what we about this topic to the phenomenon. So I have the chart, I gave the post-its. So the new admin, because the kids were right, I gave them post-its instead of, you know how they shy the kids are in class. So the post-its, they wrote it like, what's the vocab, and then what are we learning, and then what's the connection of what we're learning to the phenomenon. So the topic was meiosis. So they were writing, and the admin was like going around checking what they're writing. And then we discussed it. Maybe not to the why at the point, but at least, you know what, I've read like several. They did make connection at least with what we have learned. And the admin, I think she left a little bit happy. They're not really speaking, but I think the post-its were one way for them to participate. So it feels good. Like what Carmelita said, like at least not everyone in the room for the kids, but the admin went around. I think she talked to like 5 or 6 kids, and then she was checking what they're doing, and it felt good. Really, it felt good. For a long time, it felt good, and I've been visiting my classroom. It's been a while that you feel good, because sometimes when an admin leaves, and then you ask yourself, did I do good? Like what Kirsty said, it's like, did the kids really learn and make the connection? So feeling good is really good. I felt good. That was last week. It was the high for me last week.
I'm so happy for you. And it feels good. Yeah. It feels good when your kids know and they can justify. Or I went to go visit a class and the kid came in and I was talking to another physics teacher and we're talking about models and things. And kid was like, please don't talk about models. All I think about is lightning and the flow of electrons, and please don't do that. Which they were traumatized from my class, because they're like, we went over this and we did it. And I'm like, well, look, you learned. That makes me feel better. You understood that we're trying to explain these things. But I'm so happy. All right. Thank you everyone for sharing. So we're going to move into the next part. So tips for creating this, co-constructing more so by students and teachers. So again, when you're using that unit summary, that's a great start, right? If you're using that tracking table where you're tracking all your lessons, pulling out those main ideas, what are the kids really seeing as the most important thing, and adding that as your gotta have checklist. And the gotta have checklist can change over time. They're going to grow and they can always change. Maybe a point becomes less important because you did a bigger lesson that kind of now incorporates that a little bit better. And as they grow, again, it should be more by students, occasionally by teacher. It's great for the teacher to have a checklist and making sure students are, kind of hitting those points, but maybe students phrase it differently, but that should be okay, right? Student generated. The checklist is not a list of vocabulary words. If you go back to that, the first checklist with the balloons and the lawn chair flight, you notice they don't have too many vocabulary words in there, right? It said forces, it said balanced and unbalanced, and then motion, right? How it's moving, but not too many other things. They didn't talk about the buoyant force or gravity or all of these different vocab words that are tied to that. So it shouldn't just be this list of vocabulary words. It's composed of ideas or relationships that students now believe are important to the final explanation. And again, it doesn't mean go in without a plan. You can have your plan, but make sure that whatever students are saying kind of aligns to that, because we know ultimately what we're looking for with students. Including the word how sometimes helps you express the ideas rather than words. How forces cause any change in motion, not if forces cause any change in motion. And then when they're creating their final explanatory models, making sure they have access to this checklist. You don't want to spend all this time creating it, and then on the day they do their final models, it's hidden away somewhere. And, you know, it's not a test. It's really, even if it was a test, giving them that checklist isn't going to help them do better or worse. It just guides them in the things that they really genuinely need. So we're going to do another breakout activity. So on the next slide, you're going to choose a curriculum, and that's why we kind of had you go into your content or grade level teams. And then you're going to put yourself in the student frame of mind. So the next slide has a bunch of anchoring questions. I think the only exception to that is the physics from Discovery. It's just an idea, the momentum in a car crash, but all the rest are anchoring questions. So what you're going to do is try to think about the big science ideas that would be brought forth from sense-making activities to help explain those phenomenon or answer those questions. And then create a gotta have checklist for that given phenomenon or anchor question. Okay, so in the participant deck, you have access to these. So again, we chose one, they're parallel units, so they should all kind of be the same, no matter your curriculum, but roughly the same. Say roughly because again, they reorder them a little differently sometimes. But agree as a team which one you kind of want to focus on. If you're all HMH, maybe HMH is the best one to focus on. If you're all Discovery, Discovery. And then work to have a gotta have checklist to answer that question. Are there any questions?
How much time are we doing for this?
10 minutes is what the slide says.
Thank you.
I think we should be okay with that.
We did 13, 14 minutes with elementary.
Oh, because they have to, yeah, they have to go through the whole process of opening and all that. Yeah, 10 minutes should be good.
Sounds good. All right, ready?
Yeah.
All right.
All right. Welcome back. So just thoughts on that process. Was it hard? Was it easy? Did you get a good gotta have checklist? Was it trying to figure out what in the world this question is asking? What was your guys' process?
Yeah, for us bio, we haven't started the checklist yet. We were using the model that you presented. Like you had the first figure. Okay, so we were talking about like producing finding a quick video about population of otters. So it's a whole chapter, a whole lesson like that will take probably 2 weeks, but it's a good start for us. We were really talking and looking for information. So, and I'm gonna use this because I haven't started with, I do ecosystems last. So
Okay.
what Carmelita and I started, I think I'm gonna continue doing this with the steps that you have here in mind, leading to the checklist.
We are still on the process of planning. So as a teacher, the first question that we thought is that, does our student actually know what is sea otter? That's the first one. Do they know the importance of the existence of this sea otter? So the first thing that comes to our mind is that, do we need to show first a video about sea otter? And then after showing the video, then maybe that's where we're gonna I would say construct a phenomenon on how they can create an initial model. And then from that, maybe supporting reading articles before, because, checklist, I believe, is always on the last part of the lesson where they need to really put all the final understanding of the unit. So at first, they need to, as a teacher, you need to plan first. How would you introduce the lesson? That is the first one. How would you connect it to a phenomenon so that the student will create an initial model, and then support that with, supporting reading articles or other lessons. And then that's the time that you need to construct your initial model, and then you'll see if the student will be able to put all together all the ideas and understanding of the lesson. So that's my understanding about checklists, and that's where the final model will come up.
Yeah. Thank you. Thank you both for sharing. Any other groups this process was like?
Our group, we looked up the standards and try to match the standards with the phenomenon, and it turned out to be multiple standards, and we were discussing what standards would apply, and that's how far we got.
Okay, yeah, and again, that's a good starting point, right? Going in as a teacher with this, I have this idea about what my kids are going to need to pick out. We need to have that background. We need to understand. Yeah, thank you for sharing.
So for HMH, we talked about that in our textbook, they kind of have a guide for teachers throughout where there's students are supposed to add to their evidence notebook. And so using that as a guide can kind of, we can come up with our checklist. Thinking also about the vocabulary. So HMH, I feel like does a good job with helping teachers think about how to get students to answer the question, but it's always the time, taking that time for students to allow them to think and process this information.
Yeah. Great. Thank you everyone for sharing. So what we're going to do now, before we shift to a break, we're going to watch a few examples of a fifth grade classroom discussing they're co-constructing a gotta have in their table groups, and then we'll see the whole class discussion, and then we'll look at a secondary example of it, but really focusing on this constructing of what I believe in this video, they call it a must-have, their must-haves are, or for that gotta have checklist.
People. Model, maybe. No. You draw gravity too. It's important. Oh yeah. Maybe pattern of like yeah. A whole unit is Mount Nose. Pattern of Earth and sky. Maybe we should include Mount Nose. Patterns we see. I don't know. Mount Nose. Mount Nose. I'm not gonna write Mount Nose. Yeah.
Well, yeah, we're gonna need that, but that's
maybe patterns we see. Okay.
I know
because when we're doing the rotation.
Nose is crucial. Constellation stars. What do you like? You're gonna draw.
Mount Nose is crucial for everything that we've done in this unit.
Model, do we need? Ooh, what about directions? Because like we're from south, looking west, looking east. What about model? Yeah, sure. Yeah. Okay, good too.
What is a must-have that you feel you need to have to answer the question, what did you learn about the relationship between Earth and stars that helped us solve the problem of the missing artifact? Soliana.
Constellations.
Constellations. So do you mean that as part of your drawing and your explanation, or both? Both.
All right. So that was kind of small group to whole group. And then we're going to watch the whole group kind of come together at that end.
So this is a suggested list of must-haves. Meaning it's just to give you an idea of what you might want to include on your model to be able to explain the relationship between the Earth and stars. Now again, the front is a drawing with some little text boxes or explanation, and the back is where you write your explanations to your drawing. Okay?
So that was, again, an example from elementary. So now we're going to look at an 8th grade example.
There we go. All right, so what could be one thing that's helping to cause those different flame heights? We'll start us out and then we'll go to Luke. And so something involving sound waves. And so instead of just making like a list of words, we're gonna give us just a little bit more substance. And so something involving sound waves, where do the sound waves come from? Okay, what is the speaker doing? How do we know? Okay, so we could say how vibrations from the speaker create, and so if we wanted to say sound waves, would that be longitudinal or transverse? So we'll say create longitudinal sound waves. All right. What were you thinking, Luke? Latex. What was that? Latex. So we need the latex on there. And so involving the vibrations from the speaker, what could the latex be doing? Amplifying the sound. It could be amplifying the sound. And so maybe as a sub point, we'll put latex interacts with sound waves. Let's see what else.
All right, I know that one was a little bit harder to hear, but what she's doing is kids are kind of presenting those vocabulary, right? Those big ideas, but she's clarifying that information with them and really asking them, like, well, what do you mean by that, right? Kind of getting them to explain that process and their understanding. So there we go. Goals of pressing for evidence-based explanations. The reason we want to do this is we want them to use evidence to account for different aspects of their models. This isn't just, you know, they're going to their model, they're saying this is the way it is, but rather they're using evidence to tell us about all parts of the model, not just one. We're holding students accountable for multiple sources of information. Students don't just engage in one lesson and then can explain an entire model, right? They go through a series of lessons. They do all these lab investigations and they have all this information, and we want to hold them accountable for that. They've done all this learning. How can we have them present that to us? And then to engage them in authentic disciplinary discourse. You saw in the 5th grade classroom and even in the 8th grade classroom, they were able to talk about the ideas that they'd been exploring, that they'd been discovering together as a class. So we are going to take a break first, and then when we come back from our break, we will go into our reflection, our facilitator reflection. So thinking about that piece, right? So everyone, please enjoy a 5-minute break. Come back, stretch, see you in 5 minutes. back, calming music. Hopefully helped you recenter. All right, so like I said, we're going to go into a breakout room now. So thinking about that section where we did the gotta have checklist activity and looked at the videos, what are the points you might highlight? Logistical planning, alternative protocols, and possible teacher responses or potential challenges that you may have with doing this activity with your teachers.
Sorry, Kirsty, how many minutes?
We can do 5 minutes.
Okay,
5 minutes will be okay. Yeah.
Yeah, and really focus on the leadership aspects here. So what is, how are we going to lead this piece? What's important about this piece? All right, opening breakout rooms now.
So in thinking about this leadership part and facilitating this with your teachers at your school, what are some things you're considering? Some things that you want to make sure you hit or you may change because of your department?
I mean, I know I'm going to put Kim on the spot, but I think it's something worth noting, especially about feeling uncomfortable and not knowing. So can I put you on the spot, Kim, and explain what you just explained? I thought that was really well said, and I think it should be shared.
You want me to say it myself?
Yes, because I
Well,
think
I was saying that teachers who teach Common Core standards, whether it's science or math, teachers are hesitant to present the material because they feel like they don't understand it themselves. And I think we need to train the teachers to feel more comfortable with presenting material which is difficult to them also. And not just avoid all the topics that they don't know off the bat.
Yeah, that's powerful. I really think. Thank you, Pedro, for encouraging her to share. Thank you, Kim, for sharing. But yeah, that is definitely something that I think especially with NGSS, the not knowing is okay. And I think my kids never knew when I didn't know because I just phrased it back to them. Well, why don't you figure it out? Like, let's figure it out. Come on. And so they didn't know I didn't know, but I'm sitting there Googling too, like, wait, their question and I don't know. Let me try and fill these gaps, figure it out before them so I can, help them. But it's okay to not know. We're not supposed to know everything. We're human.
Another issue I think is the time. I mean, sometimes even for a month, we're not even having a department meeting. And they're always focused on math and English, although I totally understand that. So we seldom meet. Well, that is only for my school. And that's why I don't know how they will divide that equally in order to collaborate more often. So that is my issue, is that we seldom meet as a department.
I want to add on to it. Carmelita's right. Yes, we meet like for us before, because right now all our PDs are going to be scheduled after school. There's no more like short Tuesdays because we've completed everything. When we meet, yes, we met like every 2 weeks or every month. Okay, but sometimes something comes up for the month that you don't get to like go to these topics. Like we share ideas, we do this. So there's something for that month, for the week, for the school, that this one takes a back seat. So, and it's hard for us teachers. I can do after school, but not all of us can stay. Having faculty after school is hard enough, but having them stay like just for this, and Saturdays are hard. So I think Carmelita's right. The time constraint is if we can only focus for this one, like for probably 2 hours, and not focus on anything else or something for the month, like for this one. So I think it would help. And as unlike like when you come in for the department meeting, there's this, we had WASC, we had this. So it's just like to each his own. Like if a biology teacher asks that something, you just answer it. It's hard. The time constraint is the one that holds us back.
Yes.
I just wanted to add on to what Maria said, made me think about like, you know, the group of teachers that I support. And for me, I think it's just relevancy, right? At my school, I have one chemistry teacher, one physics teacher, one biology teacher. So it's about finding relevancy for all of them, that they could all hook onto the information that's being presented. And so, you know, I think today's PD was a really good example of how I can present my information, right? Just bringing in a general idea and getting into specifics. And I think I really enjoyed too, Ms. Kim's thought about like feeling uncomfortable, not knowing, because I always get that question, well, how is this relevant to my subject area? Or how is this relevant to, you know, physics, biology, chemistry? And so sometimes I get stumped and I'm like, I don't know, we have to try it out in order to figure that out. And that's my struggle, I think. And I think those are the things that I need to think about to help my group.
Thank you all for sharing. I know definitely at the high school level, PDS, we have specific Tuesdays and not all of them are designated. And then there's data and there's, I know, been there, and it's hard and it's very hard. And you don't know when that curveball is going to be, right? Oh, I had this great department meeting planned. Oh, but you need to focus on this today. Sorry, but it needs to be this. So definitely time is a huge factor. I know middle school, or at least the middle schools that I've been to recently, they have every Tuesday. So I think they get the opportunity to meet more, but even then it's half of the meeting is designated to X, Y, and Z. And then they're like, okay, we get 20, 30 minutes to talk about science. So time is definitely an issue. And I know the relevance was always like, oh, another bio example. No offense, bio teachers, but you guys have the most examples. And it was like, well, what about chem? What about physics? And the physics teacher is off just not paying attention because there's never a physics example. So it's, and that's what the goal of these are, right? The ambitious science teaching practices, it's not the bio teachers' practices, the ambitious chemistry teachers' practices, it's all science. So making it as differentiated as possible. And that's why we offered all the content, all 6 through 8 and all biochem physics with like, here, you guys all have something that you can create a gotta have checklist for. So try it, try engaging in this work, because this isn't just, you know, the bio teacher, the chem teacher, this is all science teachers. So thank you everyone for sharing. And as you work through your struggles, just again, make note, share. We know the people that are here, share with them. Oh, you know, with our limited time, this is how I did it and it worked out great. Or this is how I did it and it was not great. Don't try it like this. We want to hear the successes, but we also want to hear the failures, because the failures help us learn, right? We can all learn from each other. So thank you, everyone. All right, so we're going to move into our next portion. And this is a portion I think most of us, if not all of us, are quite familiar with, this wonderful CER, our claim evidence reasoning. And the CER tends to be our bread and butter for our explanations, right? Our students go in, they have their claim, they get their evidence, and they have their reasoning. So your claim, your statement that answers that question, that anchoring question, that investigative question, the lab question, whatever the question is, your claim is answering that. Your evidence is your data. So again, if it's an anchoring question, it's all the data you've collected from all the lessons you've done in the unit. If it's for the lab, it's the data you collected in the lab. And then your reasoning. And the reasoning, from my experience and from a lot of anecdotal experiences of other teachers, the reasoning is the hardest part, right? The kids struggle so much with the how or the why. A lot of times their reasoning turns into just the explanation of evidence. Okay, now I'm just telling you what my evidence is saying, instead of explaining this how or why. And one way that I kind of opened eyes, and it didn't do it for all students, but the ones that were right on the edge of being there at the reasoning, is I told them, look at your claim and look at your evidence. And what science have you explained to me? And they look at it and they look at it and they're like, well, nothing. I said, exactly. You have not explained any science to me yet. So explain the science. And so then they start thinking, they're like, well, it's this concept and this concept. Exactly. So there's your reasoning. So having them see that, yeah, we're in science, but claim evidence, we haven't really done science yet. Our reasoning is our science. That's where our why comes in. So here is a model, a template for creating a scientific argument. And you can see the CER is broken up. And again, this template can be modified to fit the needs of your students, to fit the needs of your lesson, whatever it may be. And it kind of gives you sentence frames, and Craig put it into the chat. So your claim, your evidence, your reasoning, and then this allows for peer feedback, which gets us into ASTP4, that critiquing part. Now they're critiquing scientific arguments. Is the claim clear? Is it about what is causing something to happen? And they get feedback directly next to their CER, which they can go back and on that same sheet, revise. So looking at an example, so we have a phenomenon. The example is the train car collapsing. So we're going to play the video. It's a very short video for those of you that maybe haven't seen it before, of the collapsing train car.
Gewonnen hat Herr Dr.
All right, so students would have viewed that video and gone through a series of lessons that they then created a claim evidence reasoning for, got comments from their peers on their work, and then revised their claim evidence reasoning. And again, this is in the slide deck, so maybe if you want it to be closer, I know sometimes it's hard to see on the shared screen, but you can see how detailed the evidence became, the explanation of evidence. The reasoning changed, showing that they were taking into consideration all of the different feedback that they got, and it in turn strengthened that CER that they were engaging in. All right. So we're going to just share out loud for this one, since that was a little bit shorter part, but based on the CER, that template, the different ways that you've done CER in your classroom, what are some things that you want to highlight? You know what your teachers have kind of done. What are some things you would want to highlight? Maybe you don't go over the CER part because you know your teachers got it, they're really good at it. Maybe you introduce them to the template. How would you guys take this back?
Actually, I'm using Savas, and Savas, I would say that it's really connected to NGSS. I mean, all the science and engineering practices like, analyze data using claim evidence, because especially right now, I'm just yesterday, I covered claim evidence in one of my topic in Savas. And since they are, I want them to start in developing more writing skills. And that's why most of the lessons that I give them from Savas is more on analyzing data and how they can, interpret some data as well and be able to explain what's going on and, present that data into a graph. I didn't go beyond yet because I'm focusing on the Savas. However, what I'm trying to say is that all this lesson using claim and evidence and reasoning, actually this is happening in my class because I'm following the Savas curriculum.
Yeah, and I know that Savas does offer their own template, right? Their own CER template for that as well, which definitely helps support students engaging in these evidence-based explanations and argumentation. Thank you.
Kirsty, I just have a question. I know since you mentioned having examples for physics is always a challenge, and I'm, trying to think about how might I be able to support my physics teacher, who's a veteran, and same time it's like learning NGSS. So, any thoughts on how I might be able to support and, mention how this might support his class a bit more?
Okay, so I'm not the physics expert in the room. Craig is. I've taught physics. Physics is cool enough. It's not chemistry. Chemistry is my love. But Craig, do you have any insight to how to support the transitioning teacher?
It's really getting at the why, what we were talking about earlier. What is the student perspective on their learning? What is the student experience, and why is that valuable? And it's working on that question. This is not specific to physics, right? This is just what we were talking about before. What is the student experience? Why do they care to learn about this? How is this going to help them in life? Years from now, they're not going to remember that momentum is, the change in momentum equals impulse. They're not going to remember that. But they will remember how they were able to figure out and make sense of their world. And they'll take those thinking tools with them. So yes, we want them to understand what impulse is. But more importantly, how are they figuring that out? And that's what Young Mi was talking about earlier. So it's really facilitating that shift from content to process. It's no longer about content only. It's about how do we construct knowledge about that content.
I know, again, like I taught physics for a few years before I transitioned out of the classroom. But as my physics team and we always went back to the framework to look at the process. Because in the framework, yeah, they talk about the concepts, but it's really the process that students are using. And literally that chapter on physics, I know that chapter on physics very well because of how many times I've read through it to like, okay, I understand what the content is. What process am I going to have students go through to do that? And every physics teacher I've kind of run into, I go back to the framework, like, let's look at this instructional segment. Let's look at the unit in your curriculum, whatever it is, your textbook, and let's see the process. Let's see how they line up, because I know on the curriculum maps, what our team did was we aligned the instructional segments to the, or what the DOI team did. We aligned the instructional segments to the units. So even though, each curriculum divided them up a little bit differently, like I know HMH has 8 units instead of 6 instructional segments, but we align them. And then from there, you can look and say, okay, look, one of the things, 2-dimensional motion, HMH has it. It's not in the framework. They don't need that to understand the world around them. That's not an essential knowledge. And if you want to do it, cool, but how are you getting them to access through the skills? What are you doing? How are you building those skills? And again, with the science and engineering practices, that's kind of what I always go back to. How are we using the practices to access that? Because that's the biggest shift for us. It's not me standing up here lecturing you about momentum or impulse or Newton's laws, but rather you're discovering what Newton's laws are. You may not call it Newton's second law and give me the equation right off the bat, but you're discovering, hey, that crash had a lot more force in it with the bigger car than, with the smaller one. Yeah, like just that concept, that's a concept, right? And kids can get that without knowing force, mass, acceleration. So I think that's kind of, I know in the physics world, that's where I butt heads a lot. it's a really hard one to kind of get, because even in chem, I know that they're like gas laws was a big thing, right? Gas laws are gone from high school, and we all were like, wait, what? Why? But why? But understanding that, hey, they really don't need to understand all of these different laws, but rather just the energy in each state of matter, right? And how energy flows through systems and changes. And that's kind of the bigger concept.
Pedro, with your particular teacher, I think he's open. My memory is that he's open to projects, right? So then really what's the difference between a project and NGSS? And that's that the students are figuring things out. They're going to just do some more design. It's going to be more authentic. It's going to be more problem-based rather than project-based. So what is the problem that students are trying to solve? And just those little shifts, like, just open up a richness to the projects and take them from being DOK 2, sometimes 3, to being DOK 3 and 4.
Yeah, and really that problem-based approach, if you just have engineering design problems for every unit that you're trying to solve in physics, it's a B. Physics is completely, right? You can engineer design problem. I have 9th grade physics teacher who I know who redesigned her first unit with momentum, impulse, all of that to be gliders. Her kids were they designed their gliders and they were trying to figure out how to make the most efficient glider, safest and most efficient glider. She was doing it for MESA too, but incorporating the more physics part of it. So they had this engineering design problem and this project that they're working on while at the same time exploring those key concepts. So
Thank you. That helps a lot.
yeah.
So was that project done throughout the whole year?
She did it just for the first unit. I know, like, for the energy unit, we would pick random cities around the world, looking at renewable energy and what renewable energy sources would be best for those, having students learn about the processes and then start looking at that global aspect and things like that. What else? What other ones have we looked at? I'm jumping to chem. I'm thinking of chem now. But yeah, there's different, and again, the framework offers some guidance in kind of their storyline, which kind of picks out. I know the unit that we've always every year had a really hard time with is that second instructional segment for physics, the Newton's law of gravitation and electrostatic Coulomb's law, those two coming together. We always divided it essentially into 2 units where we focused on the macro and then went to the micro, because we could never find a phenomenon that we felt really ties both together. And so, but I know that she this year, and I have to talk to her more to see how she's done it throughout, but she was trying to really incorporate more of the MESA projects that the kids would get in their 10th or 11th grade years as they take MESA, so that they kind of have what she said is a head start, but really so they have this deeper understanding and can produce better projects.
Thank you.
Of course. Any other questions? All right. So this is the Pressing for Evidence practice tool. So we've kind of shared these throughout all of the practices PDs. So again, it's developing questions as you're going through this practice. So each step, you would develop questions to ask students. And the way I like to look at it is looking at what am I planning to listen for and developing my questions that way. So what if a student just names the activity but doesn't say why the evidence for the particular, why it is evidence, for the particular part of their explanation, what questions could I ask to guide students to explaining the why as opposed to just the evidence? So again, this planning tool. And then once you've gone through, you've taught that lesson, what questions did you actually use? Because sometimes we, in the moment, we're like, oh no, those questions are not going to work. with this group of kids, let me ask these questions instead. So just reflecting again on our practice. All right. So in the learner state of mind, because this is still a white slide, we are still learners right now. We're going to go into breakout rooms, leave for 5 minutes. Let me check. Yeah, 5-minute breakout room. Where we're reflecting on all of the learning we've done throughout these PDs, these 4 big PDs. So which set of practices has inspired you the most to change your approach to science instruction? So either yours or your department's, which is, you know, which practice really is like, yeah, my department needs to do this, or I really need to do this. And then how do you plan to carry out this learning of the ASTPs in the next school year? So give you a second to kind of think about them.
We're doing breakout room, did you say?
Yeah.
Mm-hmm.
Can we do 7 minutes?
Okay, 7 minutes.
7 minutes, please.
And think of this through, should we just ask them to think about it through a leadership lens too?
Yeah, you can do it through both, whichever.
through
I know
both.
some of you are not in the classroom. So if it's your leadership lens, whichever you feel most inclined to think about this from.
All right, here we go.
Anyone else like to share? Thank you both for sharing.
Sure, I think I'll share. I know eliciting ideas is number one. We've talked about this, about students not speaking, but for my own classroom, number 3 and number 4, because I've been using the phenomenon unit chart. And right now you've given me an idea because I started with CER. I like the format, the tool again that you presented wherein they talk to their peers. So again, but it's a slow thing. Like what they said, time is of the essence. So right now, I'm taking my time now. I don't want to rush. I'd rather have the kids be more aware of the topic than rush through my pacing plan. The kids I've noticed, it's so slow. It's so hard, really. Right now, it's in the classroom. This is the most I've really put in a lot of effort for just one period for a 9th grade honors class. AP class, you know, the kids for AP, they're 10th graders, they're more. But for a 9th grade class, the effort is it's not even double, it's even triple, quadruple. It's just but I've started with that phenomenon unit chart. It's on my board. I always start with it. It's in my agenda. I always say to them, we're going through this lesson step by step. We're doing these activities. We're doing this, but always go back to the phenomenon unit chart. Always go back to the phenomenon. Always back to the making connections. So as far as for our department, just like what Mr. Gomez said, bits and pieces. Okay, within the school year as we start. So probably I know we will have I wish that we will have a department PDs before school in August, Craig, so that this will be presented, maybe not all of them, or maybe like what in our group said, that what particular thing we want to concentrate on, like focus, like for the whole department, for the biology group, for the chemistry group, for the physics group. It's a lot to take in, but it's a start. It's always a start. And I said, if you don't start right now, it's going to be harder as we move along.
Yeah, definitely. Thank you. All right. So we have one final reflection, which again, putting that facilitator hat back on. And we'll just share out loud with the group as we come to the end of our time together. But what are the parts of today's PD that you found most valuable? What are, the highest leverage pieces in supporting your science department, which some of you guys touched on in talking about, which practice is the most, or which practice resonated with you the most, and your next steps. So again, you can unmute or share in the chat, whatever you feel most comfortable.
This kind of PD, Craig and Mr. Hernandez, is really very important. Hopefully it will not stop there. I know this is our last day, but I always love to, attend more PD to improve my teaching in science, because but definitely we're trying to use these different skills and strategies. But if this will continue, of course, it will improve us more. And, and we can help as well our colleague, to improve, of course, how to teach science in general.
Yeah, I want to echo what Carmelita was just saying. I totally agree. I mean, for me, this is more like a learning opportunity at the same time that I'm practicing. However, I think, coming in for the next school year, I will come in it from a different lens and supporting the teachers that I support. So I agree, definitely continue on with the ambitious science teaching practices and seeing how I can support my group.
Thank you.
Thank you.
Thank you guys. Without you guys, it would just be me and Craig sitting here.
Oh, I know you're moving on. I just have the question for the Saturday one, Craig. There's one on Saturday. Is for LDEs only? No.
Oh, you're talking about the department chair and
Yeah.
space lead. So that's going to be a joined LD Central and LD East.
Okay.
So we hope that you can make it. You're welcome.
Yeah.
You're welcome to join in.
Okay. Yeah, I haven't. I just got the email forwarded to me last, I think Thursday. So
yeah,
I'll definitely come. It's gonna be on next Saturday, right?
April. Yes, that's right.
April
Next
2nd.
Saturday.
Yeah, next Saturday.
Yeah.
Carmelita said she didn't get the email.
I can send it to you.
Yeah.
Would you mind sending it to me as well?
Absolutely.
We can send it to the group.
Yeah, I'll
the
send
group,
it to the group.
Thank
Yeah.
you.
Yeah. So so thank you all for joining us in this journey. This is the 4th PD in the set of 4. And just because it's the end of this series doesn't mean that it's the end of our learning together, right? So Maria brought up that we have another opportunity with the it's a department chair / science lead PD. That's going to be an all-day thing. You can just attend in the morning or in the afternoon. The morning part is a leadership part that is going to be led by UCLA Center X, John Kovac and Justin Betzelberger. They're both amazing. And then in the afternoon, there's going to be optional sessions. You can attend one or all or none of them. So that'll be in the email that I sent you. So once again, thanks for being here with us, and we look forward to continuing to work with you. Also, I want to say if you've got something amazing going on, I mean, but when you have something amazing going on in your classroom, invite us. We want to come and video it. You've seen these different clips that we've shared. We want to share clips from our own classrooms. We want to share clips of our own students doing these amazing things. So we're all on a road And it's a journey leading towards something. And we know that no one is at a perfect state right now. And that's fine. We want to capture those. But if you're just trying something out, maybe a second time trying it out, let us know. We want to come in and do a little quick filming of it. And with that, thank you for being here today.
Thank you very much.
Thank you.
Yes.
We'll see you again soon.
Thank
Yes.
you.
Thank you.